Hi everyone. We're going to do a quick session on building minimal surface topologies, and I want to show you some tricks on how you can use Kangaroo relaxation to to basically develop smoother forms. So for these, I have built some sample files that you can also look at, sample forms. But I want to first cover some of the basics of how you should approach construction of meshes, and then how does Kangaroo relaxation basically work. So before I get into these, I want to show you a quick example of what we are going to do with Kangaroo. So I'm going to start with, let's say, a quadrilateral mesh surface, like a basic mesh surface. So in its essence, this basically behaves like fabric, right? So if we anchor it in some points, it will basically do kind of a physics simulation, and it will basically relax the form according to those anchoring points. So for this quad, we can look at the rendered view. I have actually one more thing I want to mention is I've enabled back faces because you want to make sure that the surfaces that you construct have the back faces turned on so that you can see which side is front and which side is back. So I have like a color here. For instance, if you go to display options, go to back face settings, I have a single color for all back faces and I have the blue. You can make it some other color, but something that is basically distinguishable, right? So when you flip it, you can see the surface normals. Okay, so in its essence, what I'm doing is basically I'm going to construct, I will also show you what this script does, but basically if you have, let's say, a mesh topology, you can actually smooth this out using Kangaroo relaxation. So what I'm doing here is actually, before I get into this, maybe we should just put this in separate. So I'll just make a copy of the Kangaroo part, and I'll just put a mesh here, right click, set one mesh. And then this mesh goes into the springs from mesh function. And all this does is basically, it looks at the edges of the mesh and then uses these coefficients to develop springs from lines, right? So because meshes are built out of faces, so these faces have edges. And that's essentially this kind of cluster, what this cluster does. And we have a few basic parameters. So the rest length factor is basically how much you want to allow the diminishing of the lengths per edge. And the stiffness is basically kind of a physical behavior of the spring. So we want to start with the initial mesh, but I want to first segment this. So I'm going to use Catmull-Clark subdivision. And for this one, I want to do 3 levels of subdivision. But here you can see if you go to mesh and then face boundaries, let's get our face boundaries. By default, it kind of rounds up the form, right? So if you want to maintain, let's say, the mesh construction while keeping the edges to be fixed, then you need to change this integer here. So you don't want to smooth the edges. You just want to maintain fixed edges. And all it will do is it will just create more quads inside of the subdivision. Now what I want to do is I want to first define these anchoring points. So these are my 4 corner points, and I want to plug them in here, set multiple points, and choose these 4 points. You don't need to think about the ordering of them. So this would basically go up to the mesh, and this will go up to the geometry, and we need to supply the anchoring points, which are here, right? So what it will do is we want to fix those corners of the mesh, and then we want to allow all the other vertices to move with the simulation. So all I have to do is now turn this to true and then false, and then you can see this is basically the relaxed mesh. So I'll do it again. It kind of happens very fast because I think it's because of this rest length. But you can see when I trigger this to be false, this mesh becomes that kind of segmented form. And I can just increase the face count. Let me see, the 4. So it's just lowered it. So apparently we need to start with 3, but we can actually do more faces, right? So if I do this to be false, that's kind of the segmentation. Now, one more thing we can try here is to show you, if I move this vertex up and this one down, you can see it kind of behaves in relationship to those anchored points. So that's kind of the cloth effect that I was mentioning, right? So I'm not only moving the input mesh, but I'm also basically changing the position of the anchoring points. And that's in essence the kangaroo relaxation, right? So this is basically kind of finding that form that conforms to these corner points and relaxes the form. Now, oh, that was kind of funny. Let's go back and do that again. So if you delete this anchor, you can see it kind of just floats away, right? So it's basically running the physics simulation. Now, one more thing you can do with this type of mesh construction, I'll just show you quickly. You can go to the top view, mesh tools, go to mesh quads. So I like actually building them in grids, which kind of helps. So if I go here and turn on the grid snap, let's see. My grid snap is on. So I'm just going to build these quads. So go to visibility and isolate this. So imagine this to be like a staircase, right? So I'm just going to build kind of these 6 faces, and then I'll just select these 3 and move this up. And this will go down. So let's go back to our vertices, push these vertices down. And these, let's see, this would have to kind of face down as well. Maybe we can push these a bit more down. So I'm just building it like a staircase, something that kind of is going to turn around itself. So I'm going to build, call this mirror, and move this here. So that's kind of the staircase, right? Staircasing function. And then let's keep building these, and I'll just make a copy of this vertically. So this will go down here. I have double faces here, which will be a problem. So you want to maintain single faces on the construction. And the other thing you want to watch out for is in the rendered view. Let's say some of these surfaces are facing in the opposite direction, right? That's why we want to visualize the back faces, because you want the surface normals in the facing direction to be the same. So if these are kind of flipped, that won't give you an accurate mesh, or it won't behave in the correct way in the simulation. So you want to flip these and make sure that you have a construction like this. And this could actually be used in the simulation too. So if I do set multiple meshes, and what I want to do now is we have loaded them up. But if I do this type of segmentation, they're not joined, right? So we might want to just first weld them. So you want to do weaver birds, join meshes and weld. And then you can do the subdivision. And for the subdivision, we don't need the sharp corners. So you can actually do a bit of smoothing, maybe the corner fixed. So I'll just do 2. Let's see what kind of shape we get. So I already get something like this. You can see it's going to probably constrain these edges. And one tool that you can also use here, which is very helpful if you don't want to put in these like corner points, because we will have a lot of them, you can look for naked vertices. This is like a Kangaroo plugin, and it will give you naked points. So you can just isolate these boundary points, and we can use them as anchoring points, for instance. So if you do true and then false, this should actually work with relaxation, but I think it's already constrained. Let's actually look at this. Maybe we should reduce this threshold a bit and run the simulation. I'm kind of seeing some sort of behavior, but let's see. Let's isolate these, hide these as well. I just want to see how the surface is kind of changing. It's changing just a bit, right? It's not changing as much. So maybe we can switch this to be a bit more rounded, like this. So again, it's just giving us just a bit. And you can also play around with this wrist length factor. But just a tiny smoothing, basically. I can also reduce this a bit. Yeah. One thing though we can try here is to smooth this boundary a bit more. And for that you need the stripper plugin. So the stripper plugin is here. If you go to alter, there is smooth mesh boundary edges. And we're going to look at other tools here, but I kind of like this one because it helps you build a topology that is a bit more smoothed out when you have like a naked boundary like this. So if you use this one, you can first segment it and then smooth the boundary. So for smoothing, you need to do kind of an iterative process. So let's say we want to run 50 levels of smoothing and we want to have like an incremental parameter, like an intensity, it's called. So if it's 0, it won't do any type of smoothing, but if it's at 1, it will do maximum amount of smoothing. So I'm going to keep it at 0.5 and do 50 levels. And then if you basically replace all the mesh connections here, so I'll go back here and then create a mesh. This will go to my naked boundary. We can supply it to the springs, and this will go as my initial geometry, and I can also look at its boundary faces. So after the initial smoothing, we get something like this. And this should also be, I think, 0, but let's see. Maybe the smoothing. If we do 2, we should do 1. So that's already smoothed out. And this one, yeah, I think that's fine. So I'll just disable the preview for this. This is kind of the shape now. And I'll do true and false. And it's actually kind of working, but I'm going to increase the number of faces by changing this level. So just a bit, right? So it's kind of smoothing out the form just a bit. So now I got kind of a rotating, smoothed out surface that is continuous like this. Now let's look at our gyroid surfaces. So I want to keep this sort of construction, which was what I wanted to show initially. But now we're going to look at how this works with gyroid. So I'm going to do show, go back here, and let's look at some of these. For instance, I have built a Costa surface here. So we can start with that one. So I'm just going to select these meshes, go to visibility and isolate. And the nice thing about these is if you build, let's say the topology correctly, right? So we need to have faces that are facing inward and outward, right? So that's kind of these two colors, and you want to maintain continuity of surface construction. And once you build that, what this code can do is you can supply all the meshes, and this subdivision will first initially smooth it out, right? So we will get a lot of faces, something like this. And when we smooth the boundary, initially you get, I mean, this will actually be kind of a circle, but we want, let's say, we want to work with other geometries. I'm going to show you why smoothing kind of helps. But you want to maintain kind of a ring that is uniformly distributed with vertices, right? So once you have this type of construction and subdivision, when you run your simulation, you can see it kind of relaxes the form. So because I have these visualized, I'm going to hide them so that we can only see what happens with the final form. So you can see it's kind of allowed to relax, and that's kind of what I get. So you can also adjust these parameters. The resting factor could adjust based on the final, like the visual appeal. You can adjust it however you want. But this is kind of what I get for the Costa surface, right? So I get something that is smoothed out and kind of relaxed. So we start with those quads, but those quads get segmented into multiple faces, and they help with the physics simulation. So I'll just show you, for instance, if you have less segmentation. So let's say we don't do 3 levels of Catmull-Clark subdivision, but just 2 levels. And you will see that we have less faces here, right? So that will affect how much the form could be relaxed. But this is essentially like a resolution issue too. We will probably talk about this more in the next phase when you're building this out of physical elements, right? So having less faces means less parts to build. Having more faces means you have more smoothed out form, but you have essentially more parts. But this is basically it, right? So that's kind of how the resolution affects the physics simulation. And we are basically doing form finding with this experiment. All right, so that was Costa's form, but I want to show you some other cool things here. So for instance, I also have the gyroid, but what I did was I started with this construction. So let me isolate this first. So I started with this construction, which is kind of what I covered like a while back, but essentially like this is built out of this module, right? This quadrant module, and we're just doing symmetrical copies of it. And you can see it's kind of, it tessellates volumes as well. So I think I had it here. So this is kind of the building block, and you can actually make arrays of it. So this is kind of one array, and it's very symmetrical. It's kind of repetitive, and you can make like you can apply the relaxation operation for the whole array. But what I wanted to do was kind of close this onto itself, right? So that's essentially a type of symmetrical gyroid construction. And let's look at how I do that. So I'm going to isolate these. So the first thing I did was I actually deleted these 2 faces on these corners. So these are kind of, you can see they're kind of sticking out apparently, like because they will connect to adjacent forms, and we have this type of construction here too, and these. So I kind of cleaned this out, and you can start seeing that if we had like a single face here, that will probably form a ring, right? And that's kind of what I did. So these corners that I deleted, I kind of replaced them. I first deleted them like that. So that's kind of what I get. And then I adjusted these faces to meet at these like corners. You can also do this manually. You can also add like another quadrant here if you want. But what I did was I basically drew like a line here, visualize these vertices, set point, set X, Y, Z, and choose kind of this midpoint here. And you can also do like a scale and push this out a bit, but scale, let's do scale from this, what's the distance? It's like 6, let's do 10. Right, so I'm basically building a mesh surface topology that is kind of closed onto itself. And that's what it looks like. So you can see it's based off the gyroid, but it's making use of this type of connectivity. And we have these very interesting boundary edges, right? And this will work great for our form finding experiment. So if I go back to Grasshopper, and if you supply this, let's see how it gets processed. So I'll just do set multiple meshes. I'll just hide the original surface. And it first joins them, so we still have the same shape. Then we do the subdivision, and that gives us a surface like this. So you can see these are the faces. And this edge is kind of smooth, but we can actually make it smoother, right? So that's why we have this smooth boundary function. And you can also see these dotted lines, those are the naked points of the smoothed mesh. And you can see it's kind of moving. It's kind of being smoothed out, right? So it's kind of displaced. So it's trying to find the kind of curve that is more elegant. And if you look at this form, that's kind of that shape. So it's also moving these vertices because it's adjusting only the boundary, but that boundary we can keep for the physics simulation, right? So all the other edges, they could be allowed to relax. So I'm basically keeping this construction, and these are the anchor points. Let's actually turn this to be true. So that's the form we are going to operate on. And when I hit false, that's kind of allowed to relax further, right? So let's actually bake this and compare it to what we had initially. So I'm going to do show, and we start with something like this. It's still tied to this. Let me disable it. But we started with something like this as a topology. These are mesh faces. We segmented each of them 2 levels. So we got like a single edge became 4 edges, and we subdivided or smoothed out the boundary, and then allowed it to relax with Kangaroo, right? So that's kind of the form I got. And I actually realized one thing. This one is looking pretty nice, but it also resembles this Batwing construction. So I'm not sure if these two are correlated, but this was the construction that I made for Batwing. So I'll just show you quickly like how it works with this one. This is you don't need to change anything about this. But if I do set multiple meshes and just choose the meshes in this construction, and enable. All right, it's already running the simulation, but if you enable, so again, it goes through, we first join it, then we do like a subdivision. Let's actually run one more level. So I'm going to do a 3-level subdivision, and we want to just smooth the edges. So that's kind of the construction I have. And then we want to smooth the boundary. So you can see like these deviations, they get smoothed out. So we can add more levels of smoothing. And the more levels you have, the more kind of rounded or circular shapes you will actually have. You can also change the intensity, which will smooth it even further. Okay, so now I'm going to hide these. That's my boundary now. So you can see it's like a very elegant curve. And I'll just do false, and that's basically it. So it's keeping these as the anchor points for the mesh edges, and it's allowing everything else to find its place in the surface. So this basically becomes a very nice way of finding these sorts of forms. So there you go. This is kind of another one. This is the Batwing. I think they're kind of similar to the gyroid construction that I made just a second ago. So let me show you if I move this around here. I'll just flip this in the other direction, but you can see like this has triple symmetry. It's like a hexagonal projection. This doesn't have the hexagonal projection, but it's kind of close, right? So that's kind of the when you look at through the angles, they're kind of similar. This is, I think, probably has more. Let me see, if you look at it from this side, I think they're kind of close to each other. So I have some suspicions, like I think they're kind of related. But anyway, so I've shown you Costa's, Batwing, and the gyroid. And this technique actually also works with multi-pipe. So if you, for instance, build, let's say, a branching network of forms, something like this, you can go to multi-pipe function, so we can actually build something here. So let's do curve and then multi-pipe. So set multiple curves. These are the curves, and node size, I guess we need a large number, so I can do 20. Something like this. Now, of course, these could be deployed in 3 dimensions, so I can move them around in different directions. Maybe this goes down. Maybe something like that. And let's make this non-planar as well. Maybe this faces down. All right, so I made a shape like that, but it's not going to stay that way, right? So it's going to change. Now, a few things, we can actually make the boundary a lot larger. And then, so when you bake this is actually a subdivision form. So if you bake it, it gives you a shape like this. And you can actually mesh it first. So if you do mesh, if you did, I think, fewer polygons, this should do it, but it actually gives me a lot of division. So one thing you can do is when you do mesh, detailed controls, I think you can change the maximum edge length. So let's see if we want larger faces. Like this edge is like 100 almost. So if I do a mesh, detailed controls, minimum edge length, I guess we could do 50. Well, that didn't actually work. Let me see again. Mesh. It's 50 millimeters. Maximum edge length is 100. Well, it kind of gives me this. So I'm just wondering. So we need a way of segmenting it. One other way you can actually control this is to get the struts. For instance, if you go to the surface construction sub D and then extract the control polygon, that would also give you kind of the rough mesh actually. And if you bake this is kind of the topology you can start with. And we can actually supply it to this operation. And let's see, we first get the Catmull-Clark subdivision. Let's see what it looks like. So we have all these faces. Let's actually reduce the face count a bit. I'm going to turn this to be true. So let's hide the construction. So we have the Catmull-Clark. And then I don't think we need to smooth the boundary because it kind of collapses it. So we can just supply it as is because this already has the naked points as the edges. And then if you run the simulation, let me show you, this is pretty cool. So that kind of gives you this type of shape. Now it doesn't maintain the kind of I guess thickness of the mesh. It kind of flattens it out. Maybe we need to consider something else here, or maybe make these larger. You can actually do that by randomizing the node size. So if I do, for instance, random, we have 1, 2, 3, 4, 5. So if I do 5 random values, going all the way from struct domain, if they go from, let's say, 10 to 30 or 40. What happened? So this is node size. That should be okay. Size points. I guess we need size points, which would be the endpoints of these. So do I need to supply this? Well, anyway, so so I think we need a way to I think I did this. Let me see. Let me go back here. Okay. So I had this sub D, and then I basically translated the sub D faces into mesh faces, right? So one way to do that is to, if you go to sub D tools, you can toggle its display, and this is basically, all right, so if I do simple controls and fewer polygons, well, it gives me a lot of polygons. That's not what I want. Sub D meshing parameters adaptive, subdivision level is all the way down. Well, this is kind of it, I guess. So it gives me something like this. Yeah, I think that's what this is. So if you build, let's go back to our curve initially. And if you do like a multi-pipe, if I do a multi-pipe, so let's bake it. If I do toggle display, this is kind of the smoothed form. You can also basically select these rings, align them to the object. Let me see, align them. I guess you can enlarge them a bit like that if you want to. And if we go back with the toggle, I guess I did this subdivision first, quad remesh. So if I do quad remesh, and you want to do a target edge length, so let's do 20. Convert to detect target edges. I think that's fine. If you do apply, yes, that's what it is. Basically, it gives you, when you do quad remeshing, it basically gives you a different resolution of the surface topology, right? But you get to control actually the size of the division, and this can be useful when you want to basically use this protocol. So I'll just get this. I'm wondering if we have the remesh, quad remesh here. We actually do. So we could do geometry, guide curves, remeshing settings. So if you do manage settings, target size adaptive. So where is this located? This is located under, okay, mesh, triangulation, quad remesh, and there's quad remesh settings. So I guess you can play around with this. So if I get this guy, delete this one. Let's actually work with this. I kind of like this one better. So we can just load in a sub D. And we want to do quad remesh. So this would be my setting. So target quads adaptive size. So let's do 50. I think we did 50 adaptive size. Detect and retain hard edges. We can do false. Sorry, true. Let's try this. Okay. And if you do the mesh edges, that's not bad actually. That's a pretty good mesh because it kind of has this nice distribution. So if I increase this, you can see it's also kind of changing the resolution or the sizes of the meshes, right? So I'm going to keep it at 50 and then supply this to my Kangaroo. I hope this doesn't crash, but okay. So I'm going to keep this as true. I guess we need to take out the Catmull-Clark subdivision because it's already segmented, right? This will basically increase the number of surfaces to be a lot. So, okay. So quad remesh. These are my settings. This is my sub D. And I'm just going to disable this for now because it's making it crash. We already have actually the mesh and might as well just supply this as is. Right, so that's kind of it. And then if I do true, let's see what we get. Again, it's a bit similar, but this time I'm kind of using the resolution of the surface construction, which is kind of nice. Right, so that's kind of what I got from this. So it's kind of, again, distributing the vertices while maintaining the boundary. Okay, so I hope that was informative about how to approach like different types of minimal surfaces and Kangaroo operations. So you will basically be given this script to work with, but you can construct your surface topology any way you want and see how you can experiment with form finding techniques and come up with smoothed out forms. That will be basically the task, and let me know if you have any questions, and I'll see you guys in another tutorial. Okay, take care.